Hello again. This is the first module for the course. Before we started moving into actual programming, actual usage of Java, and how to design and develop software, I thought it would be helpful to give just a top-level view of objects, since one of the main three themes of this course is to introduce you to the object-oriented paradigm. Just giving a top-level view of objects will help you get oriented in such a way that when we start to talk about these things, you're not completely put off by the language or confused by the language. So what we'll do here is go through this material in a couple of days, and then hopefully I won't go through these outcomes, but you should be able to do these things by the time you're done with the module. Again, it's a top-level overview of objects, and then we're going to drill down in excruciating detail as we go through the course for the different aspects of this topic. Okay, so first of all, what's an object? What is it? Think about your objects in everyday life. When we think of a software object, it may be confusing, but think about what an object is in your everyday life. A physical object is something that you have that does a specific task, and it's going to be the same for software. You're going to design software objects that do specific jobs or specific tasks. So what is an object, an everyday object? Here's one, a stapler, a red stapler. You can say what it is. It's a stapler, right? That's its category. I could give you a whole bunch of staplers, and you would say, yes, they are all staplers. They're all in that same category. And then I could give you a hole punch, and you would say that's not a stapler. It's in a different category. The name we're going to use for that is class. That's the class that they're in. And then you can describe it. You can describe it's red, it's so many inches long, it's so many inches high, it weighs so much, that kind of thing. And you can also describe its current state. So it has an X location, a Y location, which has to be defined. It's currently closed. It has, let's say, 134 staples in it, but you can describe its current state. The things that you can describe, whether you can change them or not, like it's hard to change the color, or the things that are easy to change, like the location, we're going to say those are attributes, right? But those things are describing the state of the object. And then you can also change its current state. You can move it. You can staple something, which would reduce the number of staples by 1. You could fill it back up, which would increase the number of staples. So objects are things that have state and can change state. Your software objects will do a specific job. They'll be there for a reason, and they have state and they can change state. So they belong to a specific category or class of things. They have attributes to describe their current state, and we have some kind of a method to change that state. Now, in your previous programming classes, you probably talked about functions. In the object-oriented world, we don't talk about functions, we talk about methods. Why? Because we have methods by which we can change the state. So you'll be used to that terminology in about a day and a half. Another example, a chair has a height, location, color, weight, right? These are all attributes that describe the current state. And then you have methods to change the state. You can move the chair, you can sit on the chair, you can stand up from the chair, that kind of thing. Some attributes may not be able to be changed or changed very easily, like the weight or the material or the color or whatever. What about height? Some chairs you can change the height, some chairs you can't change the height. So when you're designing an object, you have to think about what things stay the same and what things don't. And by the way, you also have to think about what you might want to include in your software. So for example, I was working with someone years ago, and they did kind of a study to see, look, if you wanted to describe everything about this object, what would you include, and of course it got ridiculous because you don't need all that stuff. They were including things like smell and taste. This was an elevator, right? How does the elevator taste? How does the elevator smell? These are things you're probably not going to model if you're trying to do a computer model of an elevator. But they were making the point that there's a whole bunch of stuff out there, and you, as the designer, have to decide what's important to you. Another example, a car. It has everything all these other things has, right? Height, location, color, weight, locked or unlocked, the engine's on or off, the gas tank is somewhere between full and empty. That's the current state. And you can change the state, right? You can unlock your car. You can start your car. You can go from park to drive. You can change the state of the fuel tank by driving. It gets lower, and then when you fill up the tank, it gets higher or fuller. So again, the thing I'm trying to drive home here, objects belong to a specific class, and that class will have attributes that describe the state and methods to change that state. Now, what happened to variables? Oh, well, for the most part, we're going to call variables attributes. Attributes are the things that describe the state. We will use the term variable if you are designing a method, and inside the method you define local variables. That's where we're going to talk about variables. And if those terms don't make any sense to you right now, don't worry, we're going to go all through it. Okay, let's do a thought exercise here. What if we wanted to design a game? Here's the sheepdog game. In the sheepdog game, you're a player who controls a sheepdog, and your job as the sheepdog is to get the sheep in the pen. Now, notice how simple this game is graphically, by the way. That's the kind of graphics you can think about when you're doing your project. You know, you're not going to do this full-blown 3D ray tracing rendering of a dungeon kind of stuff in your projects. You just don't have the time, and you don't have the 100 people that it takes working 2 years to do that kind of thing. So think simple, right? Think nice and simple objects here. What kind of objects can you I'll give you a second here. How many objects or what kinds of objects do you think we're going to need? Or what kind of classes do you think we're going to need? I'm pausing on purpose. Okay, there's some pretty obvious ones here. Pretty obvious. Well, I shouldn't say that, because if you don't see them, then you'll feel bad, right? But there's some fairly straightforward ones. First of all, we need a sheep class, and we need a dog class. And the one that most people don't think about is you need terrain. You need to put the environment in which the sheep and dog interact with each other. So you do need a terrain class. And if you look and start to think about, okay, what attributes do I need to describe a sheep? What attributes do I need to describe a dog? And I'm just putting down a few. Like we said, we can add and add and add. And it's your job to figure out what's important to you. But the ones I'm listing for the sheep, bare bones minimum, they have an X location and a Y location. They have a current X speed and a current Y speed, and they have a maximum speed. And what kind of methods? They can move, they can vocalize, they can speed up and slow down. They don't have to vocalize. It just might be fun for the game if the dog barks and the sheep baa, You have to decide. And then look at the dog. They have the exact same attributes and the exact same methods. What's the difference? Well, obviously each sheep and dog are going to be at different X and Y locations and going different speeds, but under the methods, that's where the primary difference is. The sheep move differently than the dog. The dog's going to move the way the way the player tells him to go, and the sheep are going to try to run away from the dog. When they vocalize, they're going to do that differently. When they speed up and slow down, they're going to do that differently. And then the terrain has some attributes. It's basically at the width and height, where can you go inside the terrain. And then for the pen, where's the pen X location, Y location, those need to be defined, by the way. The width and height, that kind of thing. And the terrain doesn't really have any methods. It doesn't do anything, it just sits there. Now we will talk about some informational type methods later on, but it really doesn't act, right? It doesn't really do anything. As a note, I'm not showing all the classes here. If you were to build this, you would need to have another class that controls all this. That's the game controller. And you'd still need another class that shows the graphics of this. So here's an important point. When I showed this screen and I showed these little dots and I called them sheep, I was lying to you. What I'm showing you is a graphical representation of the sheep. The sheep actually reside as a hunk of data inside the computer. And what you're looking at is that white dot is a visual representation of the sheep. and we'll go through this a lot in the course. Being able to distinguish that the thing on the screen is not the actual thing, it's a representation of the thing is important. So the sheep that are here on the screen are not the actual sheep that move around, it's actually a graphical representation. Okay? So we will go into all of that because we go through a fairly robust introductory graphics section in the course. Okay? So we need at least three types of objects: sheep, dog, and terrain. So those would be your classes. You would have a sheep class, a dog class, and a terrain class. And then you would make objects from those classes. For example, you have 3 sheep objects, but they're all from the same single sheep class. So this is part of the beauty of object-oriented design. You design the object once, but in the class, and once you design the object, you can make as many copies of that object as you want. Just like, you know, stamping out parts in a factory. Once that part is designed, you can make 1,000,000 parts in the factory, right, out of that one design. And it's the same thing here. Once you have the sheep class, you can just keep making sheep all day long and, you know, fill up that whole thing with sheep. Now the game has 1 dog class and only 1 dog object, but again, we could make it a 2-player game and introduce another dog object. Now, it's important to have this distinction in your head that the class is the design of the thing, but it's not the thing, it's the design of the thing, and then the object is the actual, what we say, the instance of that class. Now, it's important to keep that in your head. However, in just everyday usage, everybody uses the term object and class interchangeably. So that's pretty common to talk that way, but always keep in your mind, no, the class is the actual design, the object is an instance of that design, an instance of the class. So you're going to design classes and then you're going to make objects for those classes. You'll design your sheep and then you'll start making sheep. You'll design your sheepdog and then you'll start making sheepdog. Okay, so from here, I'm actually 1 slide off, but that's okay. From here, I'm going to stop for a minute, and then we'll continue on and talk about how we noticed that the sheep and the dog were basically the same class, so why would they be different? And talk about a more streamlined way to think about that and to get some more benefits out of the object-oriented methodology. So I'll be with you whenever you choose to watch the next video.